We're going to talk about how to determine how many solutions or how many times a quadratic function and a linear function will intersect. We're going to need to use our determinant. The determinant, remember, you can get a positive, a negative, or 0. So if you're looking at 1a, I see y equals 2x squared minus 2x plus 1, and y equals 3x minus 5. Since they're both equal to y, I'm going to set them equal to each other. So let's go ahead and set that up to where you have 2x squared minus 2x plus 1 equal to 3x plus 5. Go ahead and move everything to the other side so that you can set it equal to 0. So subtract your 5 from both sides, making sure that you keep like terms with like terms. So this is 2x squared minus 2x minus 4, because plus 1 minus 5, and that's equal to the 3x. Go ahead and move your 3x over. I do that by subtracting like terms with like terms. So 2x squared minus 5x minus 4 is equal to 0. Now I have a quadratic equation. I want to find its determinant. Remember, the determinant is just what's under the radical of the quadratic formula. So that's b squared minus 4ac. Let's find the determinant using our new equation. B is a negative 5, so negative 5 squared minus 4 times A. A is positive 2. C is negative 4. Go ahead and solve that out. You have 25 plus 36, right? 4 times 4 is 16, 32, plus 32. So 25 plus 32 is going to give you 57. That is a positive answer. So if I have a positive answer, I'm going to have 2 points of intersection. So on 1A, this will intersect twice. Now let's look at 1B. Again, set them equal. Negative x squared plus 3x minus 5 is equal to negative x minus 1. Go ahead and pause the video and combine your terms so that you have everything equal to 0. Now that I've got everything equal to 0, I'm going to go ahead and solve for the determinant. Remember, the determinant is what's under the radical, b squared minus 4ac. So b for this equation is 4. So 4 squared minus 4 times a is a negative 1, and c is a negative 4. So this is 16 minus 16, because a negative times a negative times a negative is a negative. So 16 minus 16 is 0. How many times will that intersect? Well, based on determinants, if I get a 0, then it will intersect only once. At this point, I want you to go ahead and plug in the original equations into your calculator. This one needs to be y1, this one needs to be y2, and then graph it. Look and see how many times it intersects. Now look at 2a. Again, I have a system of equations, so I want to go ahead and combine those. So pause the video, combine those, please. I have these two combined, so I have a new quadratic, x squared minus 9x plus 20 equals 0. Again, use your determinant to determine how many solutions you'll have, so how many times they will intersect. So b squared minus 4ac. Go ahead and get your determinant, please. Pause the video. You find out that the determinant is 1, so I should have 2 points of intersection. How do I find points of intersection? Well, I need to use my quadratic formula to go ahead and find the solution. So I want the roots to this quadratic equation that I formed. So let's go ahead and plug it into quadratic formula. So x equals negative b. So it's a negative 9 plus or minus the square root of negative 9 squared, b squared, minus 4 times a times c. Well, now, wait a minute. Haven't we already done what's underneath that radical? The answer would be yes. That's your determinant. So why couldn't I, if I've already done the hard work, why couldn't I just go ahead and say that this is plus or minus the square root of 1? Because that's what I found the determinant to be. Wouldn't that save me some time? So now I've got negative b plus or minus the determinant all over 2a. So 2 times 1. At this point, I've got x is equal to 9 plus or minus, what's the square root of 1? Well, that's 1 all over 2. Now I can find my two solutions. So you have 9 plus 1 is 10, divided by 2 is 5, and 9 minus 1 is 8. 8 divided by 2 is 4. Now I have some x values. At this point, I need to know my y values so I can go ahead and give me some points of intersection. In order to do that, I need to take my x values, which are right here, and plug them back into one of my original equations. For this, I'm going to go ahead and use the second equation. It is simpler, and I don't have to deal with an x squared. So I'm going to have y is equal to 2 times, what's the first x value? Well, it's 5. 2 times 5 minus 5. So 2 times 5 is 10. 10 minus 5 is 5. So I'm saying that one of my points is going to be 5, 5. So let's go ahead and find the other point using the same equation. Y is equal to 2 times, now use your second point, which is 4. 2 times 4 minus 5. So 2 times 4 is 8. 8 minus 5 is 3. So I'm saying that my second point of intersection is 4, 3. I want you to go ahead and plug in these two equations into your calculator and check to make sure those are the points of intersection. I think you're ready to go ahead and try B on your own, please. So I want you to pause the video. I want you to work B from start to finish. I will do the steps so that you can see what's going on, and then make sure you're pausing and working on your own. The first thing I find is my combined equation, and then I'm going to put it into the determinant to find out how many solutions I'll have. Okay, once I go ahead and solve for my determinant, I find out that's 144. It's positive, so that means I'm going to have two solutions. Let's put it in our quadratic formula. Now remember, what goes under the radical is actually the determinant. So I can take the work I've already done that goes under the radical all over 2a. So x is going to be equal to 24 plus or minus, what's the square root of 144? That's 12 all over 6. Find your two solutions. Should find that that is 6 and 2, but I'm not done. I need to go ahead and let's pull this easier equation. Let's find our y values. So I take my x value, plug it in, so y is equal to 8 times 6 plus 1, so that's 48 plus 1, which is 49. And then y is equal to 8 times 2 plus 1. 8 times 2 is 16, plus 1 is 17. So I'm saying that my solutions, my points of intersection, are going to be at point 6, 49, and my other point is going to be at 2, 17. Go ahead and plug that into your calculator and check. After you've checked and you've looked at your points of intersection, I need you to go ahead and click over to Pearson 5-11. Pearson 5-11, that's all about solving your quadratic systems.